Now we're going to talk about the sum of an infinite geometric series. And it's basically a geometric sequence. It's got something special going on. Let's take a look at the common ratio here. So if we take the second term, say r equals 1 over 25, and put that over the first term, 1 over 5. And so we remember division is always multiplied by the reciprocal. So we can take 1/25 times 5 over 1, and then we can reduce this 5 and that 25, and we find a common ratio of 1/5. That's r. Oops, that doesn't look like an r. That's r. So there's our common ratio. If we did the same thing over here, took the third term, 1 over 1/25, and put that over the second term, 1 over 25, we would still get 1 over 125 times 25 over 1. And you'll notice that 25 will go into 25 one time, 25 goes into 125 5 times, and you end up with the same common ratio. So you'll notice this common ratio is less than 1. And so we get a geometric series, an infinite geometric series, that we can add up if r is less than 1 or if it is greater than -1. So as long as we have that condition going on, we can get the sum of an infinite geometric series. Notice there's no number because it's going to go on forever, and that's just going to be the first term divided by 1 minus the common ratio. So in this case, the first term is 1/5. We divide that by 1 minus the common ratio is 1/5. We simplify and we get 1/5 over 4/5. And then just like before, 1/5 times 5/4. You'll notice that those 5s will cancel, and we end up with a sum of actually 1/4. If you go ahead and do that in your calculator, add it up a number of times, you'll get closer and closer to 1/4. If you go on forever, that's how you get to the sum of 1/4. The other example that I wanted to go over with us today in this last video is the value of an annuity compounded n times per year. So an annuity, it's kind of like a compound interest account, but instead of putting one lump sum in once, you put in a periodic payment that you keep putting in over and over again. We'll call that value P. That's going to be your periodic payment. Periodic payment, PMT. Then there's going to be R, an interest rate. So that's your interest rate. And we always write that as a decimal, right? N, that's going to be the number of times compounded per year. Number times compounded per year. So if it was, say, monthly, that would be 12 times a year, and it would be 12. If it was daily, we'd go with 365. Don't worry about leap year for this math. Now, T, as usual, T, well, that's going to be time in years. And finally, we're going to get A, a final amount. That's how much the value of the annuity is after all that time. So the formula here is that A, that final amount, equals P, your periodic payment, times the quantity of the quantity, 1 plus your interest rate as a decimal, divided by N, to the number of times compounded per year times T years power minus 1. Now notice this looks a lot like our compound interest formula, as it should. That's where this is all coming from. Now all of that makes up our numerator. We still have to divide all this by the interest rate divided by the number of times per year compounded. So if we had a problem that gave us this, let's say we put in 150 here, that would mean we're putting in $150 every time we do a payment. and 1 plus the interest rate. If I put in 0.05, let's go ahead and put this over here. That means our interest rate is 5%. Our periodic payment here is $150. And let's see, we're going to divide this by 12. And so that means number of times compounded per year, that's monthly. That'd be 12 times per year. And we're going to raise that to the number of times per year times years. So if I put a 4 there, that means we're going to do this problem for 4 years. And don't forget to subtract that 1. That's a common mistake to do. All that makes up our numerator. And then we divide this in the end by the interest rate again as a decimal, 0.05. There's our 5% interest rate. And that's going to be divided by the number of times per year compounded, 12. Now, if I was to put that into my calculator, I would have a whole lot of parentheses. And I'm going to use some space down here. So I would start way in here. Now, I may do this. I may even start by, putting a big parenthesis. Here's my whole numerator, because I know that's a lot, divided by my denominator, 0.05 divided by 12. So I really quickly got that figured out. Now let's go up here and figure out what's going on there. Let's use some color to do this. So then what I would do is I'd realize I'm going to have to do in the parentheses first, and I'm going to have to do the division part first of all. So I'm going to come over here. I'm going to put in 0.05 divided by 12. Now in parentheses, so that's done first. Now I'm going to add 1 to it. So I can put the plus 1 right there. Now all of that has to be raised to this power. So let's go ahead and isolate all of this, caret, to that power. Notice that power is actually the 12 times 4 power. So I'm going to put that in parentheses, 12 times 4. Now, all of that we have to subtract a 1 from. So let's take all of that, put a parenthesis around it, and subtract 1 from it. Lastly, we have to multiply all that by 150. So let's get one more color in here. Let's take all of this and multiply it by 150. So that's one way to see how to put it into your calculator, to have an idea of what you're doing. When we do put this in our calculator, we end up with a final answer of, what do we got? $7,952 and approximately 23 cents. It's actually 23,2781, blah, 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 but since they're paying us, we would round which way? Yeah, we round down no matter what. So there is our final amount in this case. Right there. Alrighty, folks, I hope that helps out. There's a little real-life example of how to use this, and we'll talk more about it when we get to video conference. Have yourselves a good evening. Bye.